So let's just real quick go over example number 7. And so if I were to apply those same techniques to all of the trig functions, okay, their inverses would have restricted domains and ranges in such a way that the values of x and y tend to repeat at a half of exactly 1/2 of their period, right? The only difference is that they change a little bit in the positive and negative values. And so what we do is we went over we went over sine and arc sine. And so what we did is we restricted the domain of sine, which then becomes the range of arc sine. And then the corresponding range becomes the domain. So this is something that you're going to need to know. Mr. Adams actually already made up like a Quizlet, I made a set of flashcards so you can memorize this stuff. You will want to memorize this before you take the AP exam. My goal is that we'll keep using this so much that you should. I might give you guys a quiz, not tomorrow. No, maybe next week. We might do some trigonometry, log, quiz, review stuff. We might take a day or two before we jump into the next chapter.
Wait, Ms. Jordan,
yes.
could you also show us how you do the inverse of like cotangent and all of that? Because
in your calculator?
yeah, my calculator.
Yeah, I could.
That was also because I always thought that okay, cotangent is just 1 over tangent.
Well, that would work with the regular functions, but with the inverses, not so much, right? Okay. So yeah, we'll address those issues when we get to them. Right now, what we're gonna do though is we're gonna try to find the measure. So example number 7 wants us to apply these inverses.
We can't see what you're writing.
I know that because I'm writing it out of the book. And I want you guys to look at these values that are on the screen. Okay? So example number 7 wants us to apply cosine or arc cosine. Now we could call these lots of things. And really it's convenient to call them certain things. I could call this arc cosine. I could call this the inverse of cosine. I think that's pretty much it. So just know that when Mr. Adams, I always say arc sine, but then I'll say the inverse of tangent, the inverse of cosine. I don't know why I say arc sine. I don't know. I just like saying it. So what we're saying is, in this problem, you can find the answer, but I want you to understand what it means. What it means is that if I have a right angle triangle, there is some value here, x, okay, that represents an angle. Now cosine, if you remember correctly, cosine of x will equal the adjacent over the hypotenuse. So what is negative 0.05? Isn't that the same as negative 1/2? So the hypotenuse is never negative. And if we think of the xy plane, so basically what we're saying is this is negative 1, 2. And so when we find the arc cosine or the inverse cosine of negative 0.05, I said that wrong, negative 0.5, what we're really saying is let's find the measure. Let's find what angle produces this ratio of cosine in a right triangle. Well, we could do this very easily on a graphing calculator. So let's do it. So I just got to come in and I'm going to hit. I'm going to make sure that I'm in degree mode first. And once I enter that in the calculator, in degrees, it would be 120 degrees. Now let's go change our mode to radians. and do that again. So if I hit second entry, it'll pull it up again, but now in radians, so this is degrees, or 2.09 in radians. And that really matches up what we're trying to do. Because, so what am I saying? What I'm saying is that if I map this thing on the XY plane, okay, in order to get this triangle, I'm going to have to come from my initial position, which is 0 degrees and also 0 radians. I'm going to have to come either 120 degrees or 2.09 radians. Does that make sense? Now here's the thing. What is our reference angle? Our reference angle is this angle here, right? What is it from 0 to right here? Isn't that pi or 180 degrees? So how can I figure out exactly what that measurement is in radians with regards to pi?
Yes.
How do I do that?
Well,
Subtract 120 from 180.
Yeah, so if we subtract 120, so thank you for thinking of that. If I take 120 from 180, I get my reference angle, which is 60 degrees, right? Now, what is 60 degrees? Here's the clincher. What is 60 degrees in radians?
like pi over 3.
Pi over 3. So really, to find this 2.9 in radians, I would say pi minus pi over 3. Yeah? Well, then I could make this 3 over 3 pi, which gives me 2 pi over 3. And I did it on my calculator, but I didn't need to. I could have done this in my head.
So that finds the measure of the angle.
Yeah, so the answer, this is the answer to the example question right here, those two answers. But I went a little bit further so that you guys could kind of wrap your minds around it.
Wait, aren't we supposed to convert it to pi?
Yeah.
Okay.
Another way that you could have done that is write a proportion, right?
Yeah.
Right. In other words, you could have said 120 degrees, right, over 180 degrees is equal to something pi over x. Cross multiply, you'll get the same answer.
What's something?
This is just algebra, right? Well, this is just algebra. We don't know what that value is, so we're going to plug in x. It probably doesn't help that I have x listed like 4 or 5 different times, right? I probably should have put theta here or something different. Smiley face. Happy smiley face guy. Okay.